Hi friends, welcome to my YouTube channel. This is first part of lecture 14, and in this lecture we will study circuit operation and waveforms for one phase half wave uncontrolled rectifier with L load. First we start with circuit operation. So this is circuit diagram of rectifier. In this inductor L is connected in series with this diode, and this whole circuit is supplied with this voltage source Vs, that is equals to Vm sin omega t, and this is the waveform of this rectifier circuit, this supply voltage. Now we will see what happens from 0 to pi. From 0 to pi, this supply voltage waveform is positive. So from 0 to pi, positive half cycle of waveform will apply it across this diode. When positive potential is applied to this diode, then this diode gets forward bias and it acts as short circuit. Okay. When this diode is short circuit, then this supply voltage, that is Vs, that is equals to Vm sin omega t, will appear across this output load. So from 0 to pi we get output voltage V0, that is equals to Vs, and that is equals to Vm sin omega t. Okay, now what is output current from 0 to pi? Okay, this is direction or reference direction of output current. We know that this output current is equals to inductor current, and inductor current is given by 1 by L integration of voltage across inductor dot dt, and we know that voltage across inductor is V0. That's why we can write I0 is equals to 1 by L integration V0 dt, and V0 is equals to Vm sin omega t. That's why we can write I0 is equals to 1 by L Vm sin omega t dt. So on integration we get minus Vm by omega L cos omega t plus A. Now we have to find this constant A. So to find this, we know that at omega t is equals to 0, I0 is equals to 0. So putting this, we get A is equals to Vm by omega L, and put this A in this equation of output current, we will get output current is equals to Vm by omega L 1 minus cos omega t. I am describing this derivation for your knowledge, but there is no need to remember this derivation from exam point of view. From exam point of view, what you have to remember? You have to remember this equation of current. Okay, that is equals to I0 is equals to Vm by omega L 1 minus cos omega t. Now we will plot the waveform for this current equation. Here if we put omega t is equals to 0, then this cos 0 will becomes 1, and 1 minus 1 is 0. That's why we get I0 is equals to 0 at omega t is equals to 0. If we put omega t is equals to pi, then cos pi is equals to minus 1, and 1 minus minus 1 is equals to 2. That's why we get I0 is equals to 2 Vm by omega L at omega t is equals to pi. And third point is, if we put omega t is equals to 2 pi, then cos 2 pi is equals to 1, and 1 minus 1 is 0. That's why we get I0 is equals to 0 at omega t is equals to 2 pi. So this is the waveform of output current. Okay. And we can clearly see here that this output current is positive from 0 to 2 pi. So this is important. This output current is positive from 0 to this 2 pi. Okay. Now you must remember 2 points regarding this output current. First is, we get maximum value of output current at pi, and we get output current up to 2 pi, and output current is positive from 0 to 2 pi. Okay, so from 0 to pi diode acts as short circuit, that's why drop across diode is 0. Now what happens from pi to 2 pi? as we have already derived that this output current is positive from 0 to 2 pi. So this is the concept that diode will conduct till we get this current direction positive, and we get this current direction positive from 0 to 2 pi. So this diode will conduct from 0 to 2 pi because this direction of current is not changing. Okay, this positive current means the direction of current is positive. It means current is flowing from anode to cathode, and that is like this. That's why this diode will remain conducting due to this inductor L. Okay, so from pi to 2 pi also this diode will conduct. Okay, and during conduction it will act as short circuit. That's why from pi to 2 pi also we get output voltage that is equals to Vs, and that is equals to Vm sin omega t. So from pi to 2 pi also this source voltage will appear across this load. That's why from pi to 2 pi we get this negative half cycle will appear across the output. Okay, now output current will remain same, that is equation of output current will remain same from pi to 2 pi. Okay, and what is drop across diode? As this diode is conducting from pi to 2 pi, that's why we will not get any drop across diode, and this drop across diode will remain 0. So this is all about this lecture. So important point you have to remember here is that we get output voltage from pi to 2 pi, and that is from 0 to 2 pi, that is equals to supply voltage Vs, and we get output current, and that is only positive. Okay, we get positive output current from 0 to 2 pi, and maximum value of output current occurs at this value pi. So from exam point of view you have to remember this, and you have to remember this equation, that is I naught is equals to Vm by omega L 1 minus cos omega t. Okay, so this is all about this video. I hope you like this video. Thank you. Jai Shri Ram. If you got the knowledge and concepts from this video, then please like the video and subscribe the channel. You can give your views and ask any questions related to this topic in comment box. Also share this video with your friends because sharing is caring. Don't forget to press the bell icon to get the notification of my upcoming videos. Thank you.